Here's another problem dealing with buoyancy. A graduated cylinder is partially filled with 50 milliliters of mercury. Mercury has a density of 13,600 kilograms per meter cubed. By the way, that's a lot. Mercury is a very dense liquid. It's actually denser than most other metals. All right, when a metal cylinder is placed into the mercury, it floats. The cylinder is 5 centimeters tall and 2 centimeters in diameter. But only part of it is under the mercury. The mercury level goes up to 59.3 milliliters when the cylinder is floating. What is the density of the cylinder, and what is the metal made from? Okay, so I want to maybe draw a couple pictures to try to make sure this is clear, what's being asked. So a graduated cylinder is one of these things that has little milliliter markings on it. And what we were told is that initially it was filled up to the 50 milliliter mark. Then we drop in a cylinder of metal, and because we've dropped in the cylinder of metal, the mercury level has now gone up to 59.3 milliliters, and this metal cylinder is now floating in the mercury, partially but not fully submerged. Okay, and we are supposed to find the density of that metal cylinder. So what I'm going to do is draw my free body diagram. That metal cylinder has two forces acting on it. The buoyancy force from the mercury pushing up on it, and gravity pulling down on it. And those two forces add up to mass times acceleration, but it's just floating there. It's not accelerating, so the acceleration is 0. And that means that the buoyancy force should equal the gravitational force. All right, well, the two formulas we have for these are that buoyancy is equal to the density of the mercury times G times the volume displaced, that is the volume of this cylinder that is under the mercury, not including the little bit that's sticking out. On the other hand, the gravitational force is equal to the density of the unknown metal times G times the whole volume. Okay, let me rewrite that just to make sure that that's super clear. The gravitational force is equal to mg. But the mass of that cylinder is equal to the density of the metal times the volume of the cylinder, the whole volume of the cylinder. All right, so now this says that the density of mercury times G times the volume displaced is equal to the density of the metal times G times the volume of the cylinder. So I can cancel my G's, and I can find out that the density of the metal is equal to the density of the mercury that it's floating in times the volume that's displaced divided by the total volume of the cylinder. Okay, so a lot of this information was given. We know the density of mercury. Do we know the volume of mercury that was displaced? Well, we know that part of the cylinder is inside the mercury, displacing mercury, but not all of it. Um, but this information that the water level went up, or the mercury level went up from 50 milliliters to 59.3 milliliters, means that the volume displaced is 9.3 milliliters. Now, the problem is, of course, usually we use meters cubed. So I might need to convert that to meters cubed. And 1 milliliter is 1/1,000,000th of a meter cubed. So I need to divide this by a million. So I get 9.3 times 10 to the minus 6 meters cubed. Okay, and what about the volume of the cylinder? Well, we didn't get the volume of the cylinder. We got its height and its diameter. But the volume of a cylinder is equal to the height times pi r squared, the area of the base. So that's going to be, the height was 5 centimeters times pi times the radius. We were told the diameter is 2 centimeters, so that means the radius is 1 centimeter. So 1 squared gives me 15.71 centimeters cubed. Okay, 15.71 centimeters cubed. Well, it turns out a centimeter cubed is a milliliter, but if I want to convert centimeters cubed to meters cubed, I need to divide by 100 3 times. So that's going to be 15.71 divided by 100, divided by 100, divided by 100, and that gives me 15.71 times 10 to the minus 6 meters cubed. So, the density of the metal is equal to the density of mercury. That is 13,600 kilograms per meter cubed times 0.592 whatever times 13,600, and that is equal to 80.52 kilograms per meter cubed. And looking at the problem, it looks like I have 3 significant digits in this problem, so I should round to 3 significant digits in my answer. So that is 80.50 kilograms per meter cubed is the density of the metal cylinder that is floating in the mercury. Now, the last part of the question said, well, what metal is that? And the only real way to do that is to go look at a table showing the density of different metals, and it turns out that steel has a density of 80.50 kilograms per meter cubed, so it looks like this is probably a steel cylinder. Okay, so again, that is how we deal with buoyant forces, and that is